In this video, we're going to go over sequence loops in logic in the context of the loop stimulus level sequence. This sequence is included with every installation of SoundCheck. You can access it in your SoundCheck folder under Sequences, How-To Examples. The goal of this sequence is to find out at what level 3% THD is reached on a speaker. This is done by utilizing three different loops. First, we'll set a stimulus level, and then in this first loop here, we increase 5 dB until 3% distortion is reached. We're trying to find within 0.1 dB where 3% THD occurs, but we don't want to waste time by increasing by 0.1 dB throughout. So at the beginning, we use broad strokes, and then we use finer and finer detail to try and find where this occurs. The top screen is the fundamental, but what we care about is the THD in yellow. More importantly, the distortion maximum down in the results window. And here it finally fails at 4.4. Once that level is found, we subtract 5 dB and then start adding 1 dB at a time. Once 3% THD is again reached, we subtract 1 dB and then increase by 0.1 dB at a time. The sequence completes, and we can find out that the level that THD is above 3% is at 6.6 dBV. Now let's look through the actual logic here. The first step will ask you what the initial stimulus level is. By default, it's set to -40 dBV, and that's what I chose when I ran the sequence. What gets output from here is an actual memoryless value called start stimulus level. The next step, we take that start stimulus level, which is -40 dBV, and we add loop index 1 to it. Right now, when we open up this sequence, it looks like loop index 1 has a value of 0 dB. So the first time it runs, it will be -40 dBV plus 0, which equals -40 dBV, and that outputs a value called stimulus level 1. We open up this stimulus, and we can see it's stimulus level 1. But when we look at this, it says it's 10 dBV. So how did we get that number? We get that by using the loop index. The first loop starts on the display step. If we right-click and select Configure Step, we can see how the logic is configured. The step will jump on pass to curve plus constant dB. That takes the stimulus level and adds it to loop index 1. It jumps on fail to curve minus the constant dB. After 12 repetitions, it will jump out of the loop and abort the sequence. This is a safety mechanism in case our speaker never reads 3% THD. We don't want to accidentally keep adding voltage and blow out our speaker. Because we have a repetition set, the loop index here gets enabled. We changed the name from loop index to loop index 1, gave it a unit of dB, and set it to increment by 5. This value is in the memory list called loop index 1, which we can view here. So how does this work? In this first loop, every time the step loops back to step number 3, the loop index will increase by 5. So the first time it runs, it will add 0 dB to our stimulus level. The second time it runs, it will add 5 dB, then 10, then 15, etc. Once that level gets high enough to go above 3% THD, we subtract 5 from the current stimulus level. So in this example, we got over 3% THD at 10 dB. Because 10 was over, we want to go to the last point where it passed, so we'll subtract a constant of 5 from that level. This outputs a value, and over here in the next post-processing step, very similar to the first loop, we're going to be adding loop index 2 to this. We'll take a look here at step number 18, where the loop is created. And here we can see loop index 2 is set to increment by 1 instead of 5. So it will again jump on pass to the addition step. That addition step is what sets the stimulus level, and then when it fails, it will jump out of the loop. When it jumps out of the loop, it takes the stimulus level that failed, subtracts 1 dB from it, and then starts the final loop. So this final loop is that 6 dB level, and we're adding loop index 3. That loop index 3 is now 0.1 dB. So this loop will be looking in even finer detail than the 1 dB jumps, and to find out within 0.1 dB where we fail this limit. Let's run this sequence again and try and follow along with the logic. We start the sequence and we take the minus 40 dB, adding 0 to it, until the first loop where we start adding 5 dB. We watch the level increase by 5 dB per run, and we watch the distortion level increase. So now after the stimulus level 10, it fails and we'll jump over to the next loop. We start increasing by 1 per run, and once we get to 7 dBV, the step fails and jumps to the finer loops. This loop will start increasing from 6, which was the last known good level, until it hits over 3% THD, which should be around 6.6. And here at 6.5, we get over 3% THD.